Okay, so power to power is exactly what it means. It means there is a power and it's raised to another power. My under there, thank you. So let's do some examples. Let's look at some examples here. Okay, power to power, which is the top of our tower of power. Okay. Here we go. All right, so let's look at 2 to the 5th, and it's in parentheses. So 2 to the 5th, it is raised to a power, raised to another power. There's only one base, and it has a power raised to another power. That's why it's called power to power, power to a power, power of a power, whatever they call it, okay? It means you have one base, and there's this outside power along with the inside one, okay? When you have that, when one base has a power raised to another power, you multiply the exponents, okay? Multiply the exponents. It's kind of like distribution backwards, okay? That's how I like to think about it. You're taking that outside exponent and you're multiplying it with the inside exponent, okay? And all of any exponent inside the parentheses would get multiplied by 3, but there's only one. So that's going to give me 2 to the what? 2 to the 15th. And the reason that is, if there's 3 2 to the 5th, that means it's 2 to the 5th times 2 to the 5th times 2 to the 5th. Okay. And if you expanded all of that out, you'd have 15 2's being multiplied together. Okay. That means there's 3 groups of these 5 groups of 2. Okay? So you can just multiply. That's the shortcut. Multiply that exponent. That's why on here, on your tower of power, okay, if it is a power to a power, if you notice, okay, that problem is a base being raised to an exponent, raised to another exponent, you go one level down to put the bases or put the exponents together. So you multiply the exponents. Okay. That's how that tower of power works. Let me do that. I'll do that in a minute. I don't have the marker. Okay. So let's look at another example. X to the 3rd raised to the 4th. So you'll notice there's not 2 x's. There's not 2 bases. Okay, it's x to the 3rd raised to the 4th. So I have to recognize, okay, this is a power raised to another power because that 4 is attached to a parentheses and not to a specific base. So I just multiply the 4 into the 3 and you just multiply them. So it becomes x to the, yes. It's not that it's like difficult, it's you got to make sure you're putting all these exponents together correctly. Which is why that tower of power really helped me after I've already been a student. As a teacher, it helped me. All right. What if I give you 4x cubed? All of that is raised to the 2nd power. So I have 4x cubed raised to that outside power of 2. I know this is a power to a power because that 2 is connected to a parentheses. Okay. Just like when that coefficient is at the beginning of a parentheses and we take it and we distribute it into the parentheses. Same mindset with the outside exponent. Take it and distribute it to the exponents in the parentheses. Okay, so I'm going to take the 2 and I'm going to multiply it by 3. What's the exponent of the 4? A 1. So I also have to take the 2 and multiply it by the 1. Okay, so I'm going to take the 2, multiply by the 3, take the 2, multiply it by the 1. You do not take the 2 and multiply it by the 4. Okay, it's exponents being multiplied. So this becomes 4 squared, 4 raised to the 2, because 2 times 1 is 2, and then x raised to the 6. And what is 4 squared? So 16x to the 6th. They do like you to evaluate that coefficient out, if it's a coefficient. Don't do this. Don't do 4 times 2 to get 8x to the 6th. Don't do that. Okay, that's not correct. It's inevitable. Someone's going to do it. They will forget that there's an exponent of 1 that has to be multiplied by the 2. And they'll multiply their 4 by the 2. And they'll get 8. And you better believe that that's going to be one of the other answer options if it's multiple choice. 100%. That would be another answer option. But that's not correct. Okay. So make sure you don't do that. Okay. That's why I want you to put those 1 exponents. Put those ones there so that you don't make the mistake of doing the exponent times the base. Okay. All right, I'm gonna do a few more. If you just get like the whiteboard and do a few more. I'm just making these up. Okay, so power to power. First set examples here. Power to power. Okay, I'm not going to start with just the basic ones. I'm gonna start with more complex ones here. Okay, so 2x to the 4th cubed. 2x to the 4th raised to the 3rd. So we know this is the power to power because that 3 is connected to a parentheses on the outside. All right, and then evaluate the 2 cubes. Nice. Nice. Good. 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 Yes. Awesome. Don't forget the 2 has an exponent of 1. Nice. This 2 right here has an exponent of 1. I'm going to highly encourage y'all to put that because as I was walking around, some of y'all either left it as 2 and didn't even take the 3 and think about it with the base of 2. You just left the coefficient of 2, okay? Or you did 2 times 3. So make sure you take that 3 and we're multiplying it with the 4 and we're multiplying it with the 1. Okay, you multiply exponents. Can't forget, if you don't see it, you got to put the 1 there. So that becomes 2 to the 3rd, x to the 12th. And then I love it that y'all took it one step further and evaluated 2 cubed, which is 8x to the 12th. Okay. Most of the time, this is the answer that they like. Okay, or that you'll see. And I say they, I'm whoever test you're taking. Okay.
What if there's both those answers up there?
If it's both those answers up there, then it'd be a select all that apply. So you do have to know that 2 cubed is 8. Okay. All right. Good job. A lot of you guys got that one, so awesome. 3x squared y raised to the square. Trying to keep the numbers where we can just compute like smaller numbers. I don't want you to struggle with multiplication. I want you to just learn the process, the method. Go ahead and put those ones where you don't see an exponent. That's side. Put those ones there. Good job, Laura. I'm not saying it's mandatory, but it's just super helpful to put those ones there so you don't forget about them. Nice. Nice. Good job. All right. I'm still not seeing 100% getting it. Okay. Put those ones. Take the 2, gonna multiply by the 1, 2 times the 2, and 2 times that 1. So you'll get 3 squared, because 1 times 2, and then x, 2 times 2 to the 4th, y squared. Then that's 9, x to the 4th, y squared. And some of y'all are just jumping straight to this one. That's fine. That's fine. Okay. If you know that you're doing 3 squared, that's fine. Okay. Now, I'm gonna give you a fraction inside here. X squared divided by y raised to the 3rd. I'm going to say this, you multiply that outside exponent to all exponents in the parentheses. All exponents in the parentheses. Yes, all right, y'all are so smart. Yes, from what I could see. I'm trying to look at 30 something people's boards, but okay. So just to remember, this y has an exponent of 1. So you take that power on the outside and you multiply it by the 2. You also multiply it by the 1 because that y is inside the parentheses. Okay. So then you get x to the 6th divided by y to the 3rd. Someone tell me why I can't subtract these two. What's that, Jordan? They're not the same base. I'm dealing with x's and y's. Okay, that's apples and oranges. You can't subtract these here. Okay, and you know it's simplified because I only have one x and I only have one y. There's no other x's to put together and there's no other y's to put together. Okay, that's it. That is fully simplified. I think that's good. That's good. All right, let's go on to the next one. Okay, so get your, so we're done with this page. If you want to now fold this in half and glue that one in your notebook. Okay, your tower of power should already be glued in. We are actually done with the tower of power portion. Okay, so you should have tower of power glued in and that first 3 properties completed. Trying to keep up with all my note stuff here. Okay. Now we're on to this sheet, the one that has just the two of them. Okay, now we're going to talk about negative exponents. Negative exponents. Okay. So these next two, these last two, they don't play into the tower power. Okay, they don't play into the tower power. If you have a negative exponent, which we did on the previous one, okay, then the expression is not fully simplified. Okay, if you see negative exponents, you need to make it positive. And the way that you do that, to change a negative exponent to a positive exponent, let's change this word move or flip to move. You must move the base and that exponent over the fraction line. What I mean by that? That previous one we just had was x to the negative third. Y'all remember we did 4 minus 7 and we got x to the negative third? Okay. Technically, that is not simplified because I need to make a negative exponent become positive. Nope. What you do is you move the base over the fraction line. So right now I don't see a fraction line. So I need to make a fraction line. Is this in the numerator or denominator? It's in the numerator, right? It's in the numerator. So if it's in the numerator, I need to move it to the denominator. So I'm going to circle this. It needs to go down to the denominator. So now it becomes x to the positive third. You see, I moved it down to the denominator. I move it over the fraction line. And it becomes a positive exponent. Now, if everything moves at the top, you got to put a 1 there. Okay, if everything moves out, you got to put something there. Okay. Negative exponents are usually one of the more challenging ones. You're like, oh, this is easy. Well, they can be very complex. All right, so what if I gave you, we'll just do some examples here. What if I gave you 2 to the negative third? Oh, well, I'm using the same thing number. Oh, well, just go with it. 2 to the negative third. That's going to equal 1 over 2 to the third. Or 1 over what? 8. Okay, maybe it gives you 1/8. Okay, because you take it, it's in the numerator and you have to move it down. What about if I gave you 1 over x to the negative fourth? What if the exponent's in the denominator and it's negative? That's why I didn't say flip, because you don't necessarily like flip the whole fraction. You just take the base with the negative exponent. Okay, so since it's in the denominator and it's negative, where is it going to go? Up into the numerator. So x to the positive fourth. Do I need to put a 1 underneath that? No, I don't need to. You don't, yeah, it's an understood 1. The only time you have to put the 1 is if if there's nothing in the numerator, then you do have to put a 1. Or you mess it up for me, please. So easy to fall asleep when you're and down. Okay. Right? What if I gave you this one? 10 divided by x to the negative fourth.
X to the negative.
Okay, 10 divided by x to the negative fourth. Okay, so we already know that x to the negative fourth has to move to the numerator, correct? What's the exponent of the 10? A 1. So does it need to move to the bottom? No. That doesn't move to the bottom because it doesn't have a negative exponent. So you're not flipping the whole fraction. You're just moving the base that has the negative exponent. Okay, so this, the 10 would stay in the numerator. It was in the numerator. It stays in the numerator. It does not have a negative exponent. But the x would have to move up with it and become positive. And there's nothing in the denominator anymore. You can just go, oh, that's it. That's the answer. Okay. You got to be careful that you don't just flip the whole fraction. Let's just do a few more examples over in this area. Okay. All right. 5x to the negative 2. I'm over here now. 5x to the negative 2. What's the exponent of the 5? A 1. Does it move out of the numerator? No. So it's going to stay in the numerator, but this x to the negative 2 needs to go down, become positive 2. Did you get that on your own? Yeah. What about negative 5x to the negative 2? Negative 5x raised to the negative 2. What's that, Marigold? Oh, Ellie? What'd you say, Ellie? The exponent is still 1. Does this negative 5 have a negative exponent? No, it does not. Just because you see a negative number doesn't mean it has to flip. Negative numbers are okay. Negative exponents, not okay. So the negative 5 would stay and still the x squared would flip down. Okay? The main thing here is negative exponents. If that negative base has a positive 1 exponent, it stays. See, you thought the negatives were like not complicated, but they can become complicated. Okay. All right, I'm gonna give you guys one more here. 4x squared y negative 3 all over, I should make this a good one, x to the 8th. Okay, here we are, guys. Let me zoom in a little bit. Okay. I'll give you time to have this one. Okay, that's the first step. Okay, this is where there's 2 and 1. Maybe I shouldn't have added 2 and 1 on this. Okay. This has dividing the same base and it has a negative exponent. So you have options on like your first step. Okay, now you're gonna put them together. So most of you guys are moving this y to the negative 3rd to the bottom. Perfect. You're like, that needs to move down here. Now you got 4x squared and then x to the 8th, y to the 3rd. Okay, and you're like, well, I'm done. Good job on the negative exponent portion. However, you have 2 x's here now. What do you do with those exponents? You need to minus them. You got to subtract those. You need to subtract those exponents. What does that give you for the exponent of the x? Where is it at? Top or bottom?
Bottom.
When you subtract, it automatically goes into the top. So this is 4x to the negative 6 over y cubed.
So now do you want to
Okay.
put the
When you subtract, whether you get a positive exponent or a negative exponent, you subtract, it goes into the top. Okay. Then, yes, now we got to take care of that negative exponent. Where does this one go? Down. So the final answer would be 4 on the top. That's the only thing on the top. And usually they go in alphabetical order. So I'm going to put x to the positive 6 and then y cubed. Woo-wee. That was only 2 properties in one. That's not even like very complex yet. Okay. I mean, it's more than just the basic one property, one property, one property. This had 2 properties in it. It had the division, so your subtraction, and it had moving the negative to positives. And we did that twice. Okay. Tomorrow we're going to cover the very last one. It's super easy, and then we're going to do a lot more challenging examples like we just did. Okay. All righty. That's all I have for you today, guys. Oh, yeah, you'll close that Zoom and let that start downloading.